So to begin with today, you will need three things handy. The notes booklet, and you're going to need some blank space to do a warm-up question. And you're also going to need your workbook. So if you have your workbook handy, that'd be great. Opening it up to 6.6. All right. So first thing, before you do the warm-up question in your book, you have, once again, 60 seconds to sketch these two graphs. No calculators. Make sure you put a scale on the X and Y axis as well. Time is up. Show it to your neighbor, have them inspect it, and then give feedback. Don't just say, oh, that's spectacular, but actually give useful feedback. What's good about it, what's not good about it. Okay, so hopefully you had a graph that sort of looked like this, which could be better, but if you're doing a quick sketch in less than a minute, we'll say that's good enough. Let's do this one in degrees. So I'd say that's 360 degrees. And this would have to be at 180. That would be at 0. And my maximum would have a y value of 1, minimum y value of -1. And as we talked about graphs last week, we said kind of dividing the graph up into the 4 sections that kind of correspond to the 4 quadrants is helpful. So 0 to 90, we're going up to the maximum, and then maximum back to that center line, 90 to 180. 180 to 270 degrees would be down to the minimum, and then back to the center line. Yes. Yes. So the question was, for people listening in video land, will you be expected to draw these graphs without a calculator and their transformations without a calculator? And the answer is yes. On this next quiz, and probably the test that follows, there will be a no calculator part, and that will be one of the questions where you're asked to graph something with transformations. So for cosine, starts at a maximum, ends at a maximum. Now if I think in radians, a full period would be 2 pi, so half would be pi. This point, pi by 2, and that one a little bit off. But again, for a quick sketch, we'll let it go. 3 pi by 2, maximum 1, minimum -1. There we go. Question? So the question is, what do we need to put on the scale? If you just did pi and 2 pi, that would be sufficient. Years ago, when I marked diploma exams, kind of before this current curriculum, if a student put a label on one point and said, oh, this is pi -1, and they had nothing else on the graph, that was considered enough scale to figure out everything else from. I would prefer you don't do that, but on a diploma exam, they let that go. Okay, now as we look at combining transformations, here we have some weird looking function without a calculator, not super helpful. But can you perform these transformations to redraw what would that graph look like after the transformation that's given. And this will set us up for doing transformations on sine and cosine graphs. I'm seeing lots of graphs that look good. We have a vertical stretch and horizontal stretch, both by a factor of a half. So we just get squished down vertically, horizontally, and then left 3, down 5. Any questions? No questions. Okay, if you haven't moved on from this, you can go on to the Check Your Understanding questions on page 530 in your workbook. And so you're going to sketch these 4 graphs, I guess. So on top of the first graph, you're going to graph y equals sine 2x. And then on the second grid, you're going to sketch the next 3 graphs. You'll notice some features carry over, and you're just adding one more transformation with each graph. Well, let's go over this page together. So I have the first 2 graphs done. So initially I did it wrong, and Sadi pointed that out. And I already forgot, boy, how did I get so few in here? I wonder if somebody's been robbing me. Welcome. Well, I do have other candy we'll move on to. Okay, so first, up here, we have that equation, y equals sine 2x, and that changes the period. So horizontal stretch by a factor of 1/2. So what I did was, I just went along and I started where my invariant point would be, and then said my next 0 was 4 grid lines to the right, so divided by 2 made it 2 grid lines, and then every 2 grid lines we had an x-intercept. And then similar idea, looking at the maximum, it used to be 2 grid lines to the right, and then half made it 1 grid line to the right, and then I just followed the pattern, minimum, maximum, and so on. Good? Question? Yes. But now that I'm done that, then no. Using a different color. For the next one, maybe yellow would stand out on top of black. We'll see. So for the next one, now we had y equals 1/2 sine of 2x. We had the same horizontal stretch, but now we just added on a vertical stretch. So with the green graph, I kept all the same x-intercepts, because those would now be the invariant points. Let's see, I'm going to try yellow again. So, can you see those? Sort of. What if I turn off this front light? Is it too dark for anybody in the front? We're good? Okay. So, those were invariant points. All my y values were stretched to be half as big, which means my amplitude is now 1/2 instead of 1. And then as we look at the next 2 parts, here we're going to have a translation which direction. Everybody calls out. Right. Let's get this down. Okay, we'll do a light gong for that right. Yes, to the right, pi by 4. So we look at the scale, and we notice that's pi. So I look at my grid lines and say, there's 1, 2, 3, 4 grid lines up to there. So every grid line on my graph is pi radians. So it's going to be 1 grid line to the right. So every point, one grid line to the right. And I'm not going to draw that one, but so it's going to be one grid line to the right and 3 units down. I look at the scale and I see every 2 lines is a unit. And so I'm going to start with my center line, which used to be up there, and it's moving down 3 units. So the center line is a handy guide for us when we do vertical translations or vertical displacement. I'll make that a little bit heavier. Okay, and then this graph would just come down to there. There we go. And then it's going to be one grid line to the right. So we should end up with a graph like that, where we have this as our y-intercept at -3.5. Questions with that? No questions? Okay, on the same page for you, different page for me, we have this table. So when we have the 2 multiplied to the x, it's changing things horizontally, which means my period is going to be half as big. Used to be 2 pi radians, now it's pi. Amplitude, no change, still 1. So again, amplitude is from that center line to a maximum, or center line to the minimum. Domain, all real numbers. Range didn't change, -1 to +1. No phase shift yet, so we just say that's 0 or none. But the zeros did change because of that horizontal stretch. And we'd say our zeros are at k pi by 2, where k is an integer. So let's just look back at this graph for a second. If we look at where those yellow x's are that are kind of hard to see, it's every, well, what color can I pick? I'll do red for the moment. So it's 0 at pi by 2, at pi, 3 pi by 2. And so it's 2 grid lines in between those. And so that distance is pi by 2 radians. And because our first one is at 0, then it could be 0 times pi over 2. That would be this one. And then 1 times pi over 2 would be this one. 2 times pi over 2 would be that one, and so on. So we get those for our zeros. Okay? Did you have a question, probably? Nope. All right. Once we put the half in front, now we have a vertical stretch. So the horizontal stuff is the same, so the period is still the same and will be for all the others, because we've taken care of the period with that horizontal stretch. This changes our amplitude to be half as big, and because all the others have an a value of a half, their amplitudes will also be a half. When you have a domain of all real numbers, it's not going to change no matter what kind of transformation we do. So that's the same all the way along. The range has now changed because of that amplitude change. So now we're going from -1/2 to +1/2. But there wasn't a new horizontal change, so our period is still what it was for y equals sine 2x. Once we come to this third graph, with the phase shift, is that going to change the range of the function? Call out, yes or no? That's not great, but we'll take it. Yeah, it's not going to change the range. The range will change for the last one when we translate everything down by 3 units. So both of these y values from the range decrease by 3. So -3.5 to -2.5. We do have this phase shift, which is pi by 4. We could say pi by 4 to the right, but if all we say is pi by 4, then there's a positive sign implied, which would mean we're saying it's to the right. So our zeros changed. And so now we have our first 0, since it went pi by 4 to the right. Now it's at pi by 4, but there's still a distance of pi by 2 in between them. So I'm adding multiples of pi by 2 to that first x-intercept. Any questions with that? Nope. Okay. And then when we translate it down by 3, we don't have any zeros anymore. It doesn't cross the x-axis. Any questions with the table? No questions. So we come to a summary page. When we put together all these transformations, and this formula is given on your formula sheet. And we'll have you shout out your answers. This graph will be reflected, well, we're comparing it to y equals sine x. Okay, so if we're imagining we start with y equals sine x, it's reflected in the x-axis if a is negative or a is less than 0. Yep. Oh, good for the big gong, but a soft big gong. Stretch vertically by a factor of? By a factor of? You mean absolute value of a? Oh, yeah. Because the negative is the reflection, so now we ignore it. Stretch factor is just the absolute value of a. Ooh, and the amplitude is? Yes. Absolute value of a. It's reflected in the y-axis if, boy, we're getting good. Stretch horizontally by a factor of? Oh, that was a little hard. 1 over absolute value of b. Most of us were getting there. It's just, we could have said absolute value of 1 over b. That would be okay. I think some people were moving in that direction. Usually we'll write it like this, but it really doesn't matter. They're both equivalent. And the period is, oh, let's think in radians. The period is 1 over b times 2 pi would work. Or 2 pi over b. Or if we're in degrees, it would be 360 over b. And again, I probably should be putting absolute value signs around that b, because the negative would just mean that we are reflecting. So where's that coming from? If we have y equals sine x, its period in radians is 2 pi. So if I have a stretch of 1 over absolute value of b, I'm just taking this 2 pi, multiplying it by the 1 over absolute value of b, which is the stretch factor. So that's where this is coming from. If this was a 30-2 class, they'd give you that on the formula sheet, but it's not, so you don't get it. So you just need to know that. Both for radians and for degrees, we need to understand both. Here I threw in a tangent function, just because tangent is different. The period for y equals tan b, what would that equal in radians? 17. That's an interesting choice, but incorrect. What's the period of y equals tan x? Was pi. So this would be pi over the absolute value of b, or 180 degrees over the absolute value of b. So that's a little parenthetical, because it's not referring to the equation we had at the top, which was the sine function. Back to the sine function. It's translated horizontally by how many units? Yes. And so its phase shift is? Ooh, that's even better. C units. Translated vertically by? Oh, we're improving all the time. Vertical displacement of? I need 2 mallets. All right, that was exciting. Woohoo! Well, let's just do some more graphs. And that'll be the real focus. So when we did chapter 3, for many of us, we like to do mapping to find new points. So we could do mapping, and then we'd look at, for example, this first one, I'd look at probably these 5 key points and say, what does the mapping do to those points? That'd be one option. I'm not going to do that. Another option would be to go through the different transformations the way we did with that what was that called? Construct understanding question from your workbook, where we do the 2 stretches and then we do the translations. I'm not going to do that in that order. Now, when we did chapter 3, I said we would always do RST, reflection, stretch, and then translate. With trig functions, I find it easier to translate first. So I'm going to guide you through the process that I follow, and with a bit of practice, I think you'll probably find it easier as well. If you want to use a different process, that's perfectly fine. So I've listed out these pieces of information in the order that I think them through. So I start with vertical displacement for number 3. What is the vertical displacement for this function? Volunteer, look for a hand, yes. 2 units down, yes. So I'm -2, because that tells me the direction as well. So then what I do right away is I sketch my center line. So I know it's going to be 2 units down. I wonder if this one moves. It does. So there was my center line, moving it 2 units down. That's where my center line is now. Next, I look at the amplitude. Amplitude for this function. Anyone? Is 3. So then, I get out my ruler again, and I say, well, my maximum has to be 3 units above my center line, so up here at 1. My minimum has to be 3 units below my center line, so down here at -5. Yes. Who told me the amplitude was 3? Somebody over here. Ahmed, was it you? How did you know the amplitude was 3? Yeah, the A value here gives us the amplitude. So I first look at B, and then I look at A. And so that gives me the boundaries for my graph. So I know my graph is going to oscillate around that center line, hitting that maximum and hitting that minimum. Then I look to see what's the phase shift. Horizontally, what is added or subtracted inside with the x? Inside here, there's nothing, so there's no phase shift. So that tells me, since I'm looking at a cosine graph, it hasn't shifted left or right, so my maximum is still on the y-axis. So I look for that starting point for the function. Finally, we're looking in radians. What's the period for this function? Oh, that was the c value I looked at. And the period is 2 pi because my b value was 1. So I'm thinking, oh, 2 pi over b, which is just 2 pi over 1, 2 pi. So that tells me I have a complete period by the time I reach 2 pi. Since I started at a maximum, at 2 pi, I'll be at a maximum again. And then I use the 4 sections of the graph. Halfway between the two maximums, I'll be at a minimum. Halfway between each minimum and maximum, I'll be on the center line. And that gives me my 5 key points for sketching one period. And then I'll just continue that pattern for the rest of my grid. And I'll just now just count grid lines. So 3 to the left, I'll be at the center line. 3 more, I'll be at a minimum. 3 more at the center line. 3 more at the maximum. And there's my graph. Any questions with this number 3? Nope, let's do number 4 together as well. So again, I'll start with looking for the vertical displacement. Well, for all of these, I need to know the shape of the graph first. So that's why for the last couple of classes, I've given you a minute to sketch what's the graph of y equals sine x, y equals cos x. Because you should know those two graphs really well. So I've already given it to us on the grid here. Typically, you won't be given that. You'll need to sketch it for yourself. Probably. So the question is, how accurate do I want the graph? So all of these points should be in the correct place. So everywhere I put a dot, those are the key points I'm looking for. Here I'd say, well, that's a little sketchy because, well, I have the dot, but it doesn't look like it's really reaching the maximum. So would I deduct? Mr. Sue and I would have to have a conversation. I'll blame my alignment, but your pencil aligns very well on your piece of paper, so you won't have that problem. Another common mistake is that people will use a straight edge. Do not use a straight edge anywhere on this curve because it's curved everywhere. And another mistake that's sometimes made is that if you use a straight edge, that turns into kind of a point there. We don't want it pointy. So it should be the smooth curve, kind of like we've drawn up there. We don't want any sharp points or valleys. Oh, also I'll look at the edge here. Did you draw it so it looks like it's going to continue going up, kind of like this? If it looks like it's going to continue going up, I'm going to circle it, take off a mark. Because it doesn't continue going up, and I want you to communicate that in how you draw it, that it's curving to horizontal, as though if we had more grid, we could keep it going down again. So we'd have a maximum at that point. Those are some of the key places that people make mistakes. And then it's just a matter of being careful, like putting the point there but drawing the line just beside the point. And I'll say, what? I can't give you full marks for that. So yeah, just be careful that you're going through all of your points. Okay, next one. Vertical displacement. So that's my d value, 0. So where my center line is on the x-axis, it's still there for my transformation. Amplitude, my a value, 1. So there's no change in my amplitude. So I am going to draw this dotted line for the maximum and for the minimum because it's helpful. Don't do a solid line. Solid lines, I'll assume, are part of the graph. So if you draw a solid line, I'll say, well, how come this is horizontal? If it's a dotted line, it's not an asymptote, it's just a guide to help us sketch. Phase shift. Armahan, what's the phase shift for this function? Pardon me? Negative pi by 3. I agree. So, at this point, I need to look at my scale. And I see there's pi. So that's 6 grid lines. So 3 grid lines. It's pi by 3, but I want to go in the negative direction. So I'm going to be here at negative pi by 3. So then I can plot my starting point. My sine graph started at the origin, but now that I have this phase shift, negative pi by 3, that's my new starting point for the graph. So I have a minimum, I have a maximum, I have a starting point. Now I need to figure out where does one period for this graph end. So I look back up here, my b value is 2, which means my period is 2 pi over b. Which is pi radians. So again, I come back to the scale. 6 grid lines was pi. So from my starting dot, I want to go 6 grid lines to the right, and 2, 3, 4, 5, 6. That's going to be the end of one period. So that's where the graph starts repeating itself again. And then I use the 4 sections of the graph. Halfway in between there, I'll be at the center line again. Halfway between the first center line point and the next, it goes to a maximum. So sine curves up to the maximum first. The next one will be at a minimum. So now I have one period. And I can use those 5 points and the pattern from it to sketch more points. So I'm going to keep going. I'll use a different color just so that stands out as my first period. Every 3 grid lines I had a 0. And I'll keep that going in both directions. In this case, it's a 0. If it had been translated vertically, then it would have been just on the center line. And then plot minimums and maximums. And I think I mentioned it last week, but when I'm sketching these graphs, I actually do it in the 4 sections when I have it on a piece of paper. So I'll turn my page, so I'll go back to the first one, and I'll sketch this part with the page upside down because my wrist curves that way naturally. And then similarly, I can do this part, which I can't do now, but I do that part with the page upside down. I'll turn the page right side up, and I'll do this part, and then I'll do this part. And then I'll twist the page a little bit, I'll curve this part and curve that part. So I do it in little pieces, just being careful that I'm connecting it together well, so that the curves are always going the direction my wrist naturally curves. And then hopefully the graph looks a little better. Any questions with number 4? Okay, let me give you a head start on number 5. Let me finish off number 5 with you. So I've looked at the vertical displacement and I drew my dotted line for the center line at y equals 3. Then I looked at my amplitude, and so I went 2 units above the center line and 2 units below the center line. Any questions up to there? Okay, next my phase shift. Phase shift is my c value, which is 0, which means the starting point for my sine function is on the center line where it intersects with the y-axis. Then I figure out the period. So my b value is 1/3. So my period is 2 pi over 1/3, which is 6 pi. Well, there's a problem. I can't find the end of my period on my grid. So I have to do some thinking. And so I would think, again, if I think of the 4 sections of the graph, if I go from the center to the maximum, typically that would have been 1/4 of 2 pi, right? So it would have been pi by 2. So now I'm thinking I have this vertical or horizontal stretch by a factor of 3. So instead of being pi by 2, it's going to be at 3 pi by 2 to get to my maximum. So I'll look at my scale and see there's pi. 3 grid lines was pi by 2, so 9 grid lines will be 3 pi by 2. And that's where I'll reach my first maximum. So now rather than thinking period so much, I'm thinking of the stretch factor. So I didn't sketch the graph of y equals sine x, but let's look at it back on this one in number 4. So here we had the graph of y equals sine x. I'll make that a different color. So there's y equals sine x. And what I just observed was from here to there. So that distance from my starting point on the center line to the first maximum for y equals sine x, that was pi by 2 radians. So now I took that pi by 2 and I tripled it down here. So there's pi by 2, 2 pi by 2, 3 pi by 2. So I tripled that distance from that center line to the maximum. So my graph will curve kind of like that. And then that pattern is going to be the same in the negative direction. So I'll go 9 grid lines to the left, and there I'll be at the minimum. So that's as much of the graph as I see. Any questions with number 5? Nope, I'll give you some more time on number 6. Okay, just before I go over number 6, I want to look back at number 3 again just briefly. So because I was doing things in a different order, I didn't stretch first. What's happening is I'm stretching around a different line rather than the x-axis. So what I did was I started by moving my center line from up here down to here, and then I'm thinking of that as being what I'm stretching around. So that's why, so I don't think from there that I'm stretching on the y-axis, because then that would move the center line again. I need to keep the center line there and use the amplitude to stretch around that line. So we didn't do that in chapter 3, and we're not really required to do it. But with trigonometry, I just find it easier to find that center line and use the amplitude to do the vertical stretch around that. So when we come to this one, number 6, we have the vertical displacement of -4. So again, my center line is going to be at -4, y equals -4. And let me make that a little bit bigger. So y equals -4, there's my center line. And then I looked at my amplitude, which is 1/2. So I go up 1/2 a unit from there and down 1/2 a unit for my minimum and maximum values. Any questions with that much? Nope, we're good. So then I look at my equation. My phase shift is pi by 6 to the right, or positive pi by 6. So then I think my graph is a cosine function. If that's where pi is, this is where pi by 6 is. And for the cosine function, it starts at the maximum, so there I get my starting point. Then I'm going to look at the period. B is 3, so my period, 2 pi over 3. Well, again, looking at my scale, since one grid line was 1/6, my next grid line would be 2 pi by 6, which would be pi by 3. So if I want 2 pi by 3, I want twice as many grid lines, so I want 4 grid lines. So I'm going to look 4 grid lines to the right, and that's going to be my period. And since my graph started at a maximum, at the end of the period, it ends at a maximum as well. And then I use the patterns, the 4 sections to the graph. Halfway between two maximums, I have a minimum. Halfway between minimum and maximum, I'm on the center line. So I have that as being my first period. And then I'm just going to keep that pattern going to sketch the rest of the graph. So it'll be center line, minimum, center line, max. And same thing in the negative direction. And then connect the dots with a smooth curve. Any questions with that one? So any of these you should be able to do without a calculator once we reach our quiz in a week and a day. No, week and 2 days. A week from Wednesday. All right. Next page, we shift gears slightly. And now we want to find an equation given a graph. So we need to look for those 4 features: amplitude, center line, horizontal translation or phase shift, and then period. Now the wording of this question is a little bit different because they're asking for a sinusoidal function, which has the word sine in it, so we think sine, but this could mean either a sine graph or it could be cosine. And so it's your choice which one you want to do. And because it's periodic, it has this repeating pattern, there's more than one answer that would be correct. Actually, an infinite number of answers, but we'll try not to get too silly with it. So let's go through and figure out some of the different features. What's the first thing you would like to find? Anybody? Yes? Okay, so you found vertical displacement was 3 down, and how did you get that? Uh-huh. Okay, so you look to see kind of what's halfway between the minimum and maximum, and you eyeballed it and found that y equals -3. Whoops, let's redo that. So we have this. So eyeballing is good. Sometimes we're not given a graph, we're just given information. So what we can do as well is we can think of this is the average between the minimum and the maximum. So what we could do, and what will always work, our d value will be the max plus the min by 2. graph like this, probably for many of us, it's easy enough just for us to look at it and figure out. But there are times that the formula is helpful. You're not given this on a formula sheet, so it's just something you have to remember. So in this case, if we looked at what we have here and used the formula, my max, if I look at the scale, that looks like it's -1/2. My minimum, -5.5. And divide by 2. So -1/2 and -5.5 is -6 over 2, which does give me the -3. So there's our d value. Next, let's look at the a value. A value is amplitude. So I want to look from here and say, oh, how far up does it go? How far down does it go from the center? And it looks like 2.5. Could write it as 5/2, could write it as 2.5. Again, if we're given a graph, it's relatively easy to see. What we could do is we could say, well, if I look at my minimum and maximum values, if I subtract them, that'll give me the distance between, and then if I divide by 2, it'll give me the amplitude. So a formula for the a value would be max minus min and divide by 2. Again, not given on the formula sheet, but sometimes it's useful. So we have A and D. Now let's look at our B value. We want to think about the period. So I look at my graph. Here there's a maximum right on the y-axis, which is kind of nice. So then I'll look to my next maximum and say, how far is that? So I look at my scale. 2 grid lines is pi by 4. So 4 grid lines will be a pi by 2. So my period is pi by 2. Well, we know that our period is also equal to 2 pi over b. So if we knew the b value, then this is how we'd find the period. And we could just look at the pattern here and say, oh, well, what would b have to be? 4. So we could kind of look at the pattern and guess and say, oh yeah, b would have to be 4. Or we could rearrange this. So we'd multiply the b up here, divide the pi by 2 on the other side, and we get a variation of this formula, which says b is equal to 2 pi over my period. Again, not given on a formula sheet, but a useful relationship to have handy. So we'd have 2 pi over pi by 2. And I'll show the fraction division because it'll help some of us. That's 2 pi divided by pi by 2, or 2 pi times 2 over pi. Pi's cancel out. And we get 4. So our b value is 4. Good up to there? All right. Now the c value. So now we need to make a decision. Am I looking at a cosine function, or am I looking at a sine function? And I get to pick. Anybody have an opinion? What would you like to use? Sine? Somebody would like to use sine. Okay, so let's pretend this is a sine function. So if there's a sine function, then our graph needs to start on the center line and curve up as we go to the right. So then we say, well, this could be a starting point, because then we curve up, or this could be a starting point, because there it curves up as well. So we could have a c value of negative pi by 8, and that takes us to that point there. Because we saw 2 grid lines was pi by 4, divided by 2 would be pi by 8. So that's one possibility for the c, which would mean our equation would be y equals a is 2.5. I'm going to go with 5 halves. Sine my b value of 4. My c value was to the left, so it'll be plus pi by 8. And my d value was negative 3. So there's one equation we could use. Questions with that equation? No questions? Okay, let's do a different one. We could say that our c value is 3 pi by 8, which would be this point here. Because now I'm 3 grid lines to the right. Every grid line is a pi by 8. There's a 1 pi by 8, 2 pi by 8, 3 pi by 8. And that could be the starting point for my graph. And so then my equation, the only thing that changes is my c value. So I'll have y equals 5 halves sine 4 x minus 3 pi by 8 minus 3. There's a second equation that works. Yes. Is there a blue one at the bottom? No, because I'm starting on the center line and then I'm curving up as I go to the right. So it's still a sine function. But I could write an equation for a cosine function. So let's do that. This is such a mess up here, I'm going to erase what I've drawn on the graph. And given the choice, I kind of like the cosine option because cosine starts at a maximum, which would mean this has no phase shift, which is just a simpler equation. So if I did a cosine function, and I'm going to take up space here, I could say my c value is 0. And then a, b, and d are all the same. So I could have y equals 5 halves cosine 4x minus 3. And there's the simplest equation of the 3. And there are an infinite number of other possible answers. Question, and then we'll go to lunch. Praveen. Yep, on a test or quiz, you could write any of these. And all the other options that would come out. Okay, so there is check your understanding. Between today and tomorrow, it would be good if you did that, and then we'll start tomorrow with going over that question. Thank you very much.